Hello students, today we'll solve one beautiful problem from CSIR NET 2019 December. So in that question, they have asked which decay is allowed. To solve this question, we'll apply that conservation laws. So in decay A, that is neutron goes to pi plus plus pi minus. So let us check charge conservation noted by capital Q. The neutron is neutral, so that number will be 0 here. On the right hand side, pi plus, so it will be plus 1. And for pi minus, it is minus 1. So charge is conserved. Okay. Now we'll check lepton conservation noted by capital L. Neutron is not leptonic particle, so obviously this number will be 0. On the right hand side, pi plus and pi minus, again this number will be 0. So it means L is conserved. Now we'll check baryon conservation. On the left hand side, you have neutron, it is baryon, so obviously this number is plus 1. But on the right hand side, you have pi plus and pi minus, right? So both are not baryonic particle. So obviously this number is 0 for both, right? So on the left hand side, you have plus 1, but on the right hand side, you have 0. It means baryon is not conserved in this decay. So obviously this decay will not be allowed, right? Now we'll check decay B, that is mu minus goes to E minus plus photon. Okay, so let us check that charge conservation Q. So on the left hand side, you have mu minus, so this number will be minus 1. On the right hand side, E minus, so this number will be minus 1. But for photon, this number will be 0, right? So here also charge is conserved. Now we'll check lepton conservation or total lepton number conservation. So for mu minus, it is plus 1. On the right hand side, we have E minus, again this number will be plus 1. But for photon, this number will be 0, right? So no problem with total lepton number conservation. Now we'll check L mu. L mu means muonic lepton number. So on the left hand side, you have for mu minus it is plus 1. But for E minus, this number will be 0. And again for gamma, this number will be 0. So it means on the left hand side, you have plus 1, but on the right hand side, you have 0, right? So L mu is not conserved. So that's why this reaction is not allowed. Now we'll check decay C, that is N goes to P plus pi minus. So let us check the charge conservation. So N is neutral. So obviously this number will be 0. Proton is positively charged, right? So this number will be plus 1. And for pi minus, this number will be minus 1, right? So charge is conserved here. Now we'll check that lepton conservation noted by capital L. So none of them are leptonic particles. So obviously this number will be 0. This implies L is conserved here. Okay. Now we'll check baryon conservation. So neutron is baryonic particle. So it will be plus 1. On the right hand side, proton, again it is plus 1. And for pi minus, it is 0. So baryon is conserved. Okay. Again, S will also be conserved because for neutron, S is 0. And same is true for proton and pi minus. So for all particles, S means strangeness are 0. So S is also conserved. But this decay is not allowed because you see the rest mass of neutron is less than the sum of the rest mass of proton plus pi minus. For any allowed decay, the rest mass of reactant should be greater than equals to the rest mass of product. So that's why this decay is not allowed. Now we'll check decay D. K0 goes to mu plus plus mu minus. So you see K0 is strange particle. So this decay will be allowed through weak interaction, right? If that conservation rule is satisfied. So we'll check that conservation. So let us check charge conservation. So for K0, this number is 0. For mu plus, this number is plus 1. For mu minus, this number is minus 1. So charge is conserved. Now we'll check that lepton conservation. On the left hand side, K0, this is 0. For mu plus, it is minus 1. And for mu minus, it is plus 1. So L is also conserved. Okay. Now we'll check L mu for muonic lepton conservation. For K0, it is 0. Okay. And for mu plus, it is minus 1. And for mu minus, it is plus 1. So L mu is also conserved here. But you see S, K0 is strange particle. So obviously this number is plus 1. But for mu plus and mu minus, S is 0. So on the left hand side, you have plus 1, but on the right hand side, you have 0, right? So it means S is not conserved, but all other quantum numbers are conserved, right? So this decay is allowed through weak decay. So correct option is D. Thank you.